Hi guys, Mr. Rocco again. This will be the second video for this week. This one is going to be all about moisture, looking at things like relative humidity and what's called the dew point temperature. So moisture exists in our atmosphere in three ways, right? You have your three phases: solid, liquid, gas. In the solid phase, we're talking about ice and snow. In the liquid phase, we're talking about rain or cloud droplets. And in the gas phase, we call it water vapor. Most of your moisture comes from the oceans, right? The Earth is 70% ocean. And we'll get into that down the road, the water cycle, which you probably covered in earlier grades in school. Step one is to get the moisture into the atmosphere. And so most of your moisture, like the moisture that we're getting today as it's snowing outside, that's coming from the oceans. There's two ways to get water into the atmosphere, water vapor: evaporation and transpiration. And what they do in earth science is take the two words and combine them into one big word called evapotranspiration. So evaporation is going to come from your oceans, your lakes, your rivers, your bodies of water, right? Water is going to evaporate off the oceans into the atmosphere. Plants and trees do what's called transpiration. And the way I try to remember that is, here's a picture of some trees. The word transpiration starts with T, and so does trees. So trees and plants transpire. That's, in air quotes, sweat, right? That's how they sweat. Your body, the human, right, sweats. We call that perspiration. Both of them have the spire in there, which has to do with water and sweat. So trees and plants transpire. That's how they get rid of their water. Humans perspire. And so what they do is they take the word evaporation from the water and transpiration from the plants and trees and put it together, like I said, into a big word. They take the evapo part and transpiration and make one big giant word, evapotranspiration, which is all the water that's going into the air from your oceans and your plants and trees. The word humidity has to do with water vapor. So it's a measure of the amount of water in the atmosphere. Now, this is the broad umbrella term, sort of the general term is humidity, dealing with the amount of moisture in the atmosphere. And then there's two other specific terms that go underneath that. One is called absolute humidity. So absolute humidity is the actual amount of water vapor in the air at the time. Like how many grams, they can measure it in grams, how many grams of water vapor there are in the air. Now this goes back to some things we've talked about a little bit, but let's go over it again. Colder air is heavier, more dense, and so cold air, the molecules are too close together, cold air. And so if you have air that's cold, it can't hold moisture, right? And that's why I was saying, and especially in the last video, cold and dry go together. So I try to tell kids, think of dry skin. When do you have dry skin? Oh, Mr. Rocco, I have dry skin in the winter. Right. Chapped lips, things like that. When it's what? Oh, it's cold outside. Right. So cold and dry tend to go together. So the colder the air, the less moisture it can hold. Again, because colder air molecules squeeze really tight together, right? And therefore I can't fit a lot of water molecules between those tightly packed cold air molecules. And then the opposite. When air gets warmer, it spreads out. The molecules spread apart. Well, now, because the molecules are spread out, I can fit a lot of water molecules between those warm air molecules. So colder air, less moisture. Warmer air, more moisture. This shows both situations. So on the left, you have warm air. It says a parcel. When you see that on a question, some kids have said, what do you mean by parcel? Just an amount of air. So it's some amount of lighter air. It's warm and moist, and therefore I can fit a lot of water in there. So warm air, it says abundant space is available to hold water vapor. So the warmer the air, the more spread out the air molecules are. See, these brown circles are the air molecules, and then you can see I can fit a lot of water in there. Over here on the right, this would be a typical winter day, right? It's cold and dry. The molecules, the air molecules are closer together, and therefore, as it says here, only a little space is available to hold water vapor. And so you can't fit as much water in between cold air molecules. So cold air tends to be heavy and dry. Warm air tends to be moist and lighter. Now there's what's called relative humidity. Relative humidity is always a percentage. So it's the actual amount of water compared to what the air can hold. When air reaches its maximum amount of water it can hold, and that's going to depend on the temperature. If it's at a certain temperature, it can only hold so many, let's say, grams of water. When it reaches the full amount, that's called the saturation point, right? The word saturated means full, right? If you take a towel and soak it in water and it's totally saturated, that means every little bit of space inside that towel, the fibers, right, the towel cloth fibers are taking in as much water as they can possibly hold. It's reached its saturation point. So think of the air like a giant towel or sponge. It can only hold so much water, and that, again, depends on temperature. Relative humidity is what percentage of that air it is holding at that current time. So let's say, this is a box representing some air, and this box can hold, 50 grams of water vapor at a certain temperature. But let's say right now this box has 25 grams of water in it. So if its saturation point is 50, that's what it can hold at its capacity. But currently, the actual amount of water is at 25. Well, what is 25 compared to 50? That's half, or you're at 50% relative humidity. So relative humidity is just what percent of the air is full of moisture at the time. Now, most students I say, when do you think is a best chance of some kind of precipitation? Well, the air should be full of moisture, right? So where would you want to be? Close to 100%, right? So when the air reaches saturation or 100%, that's typically when you're going to start to see snow or rain or some kind of precipitation. The air can't hold any more water in the atmosphere in the phase of gases, water vapor, and so it condenses, forms those clouds, and then those clouds reach a saturation point itself. Even clouds become more and more full of water to the point where they can't hold that water anymore, and they release it in the form of snow or rain or some kind of precipitation. Does it have to be 100% relative humidity to rain or snow? No. But if the air was only at 50%, do you think it would be raining or snowing? No. You want to be close to 100. It could be 80%, 85%. I've seen rain. 90% is decent. You want it to be definitely closer to 100%. 50 isn't going to do it. 50% is not going to create rain or snow. This just shows a warm air versus cold air. So again, warm air can hold more moisture. So this box is supposed to represent warm air. Warm air holds more moisture. The top of the box is the saturation point, meaning if we filled this box completely with water, it would be at its saturation point. As we said a minute ago, cold air holds less moisture, and that's why this box is much smaller, right? Cold air can't hold as much. So if I filled, again, this box completely full of water, it would be at its saturation point. Okay, when we're talking about humidity, there's two temperatures you want to look at. The actual temperature outside, which is the air temperature, and another temperature called the dew point temperature. Dew point temperature is the saturation point, when the air is at 100% relative humidity, when the air is totally saturated or full of moisture. And so this box is showing you both numbers. And so to be saturated, just as I showed you before, the air temperature, let's say outside, was 40 degrees. That's the air temp. To be saturated and reach the dew point, the air temperature needs to be 20 degrees. So the dew point temperature is telling you on that particular day, at 20 degrees, the air would be totally saturated. And that's what it says here. If the air temperature cooled to this temperature, right now it's at 40, but if the air temperature dropped, and that's why I have this arrow, and it cooled to 20, then the air would be saturated. The air temperature has reached what's called the dew point temperature. Now, in this particular case, let me reset this. Right now, the air temp is 40 and the dew point temp is 20. The box is half full. So what percentage? It says if this air is containing only half moisture, water vapor, it's half full. So what's its humidity? Hopefully you're saying 50%, right? Because 20 compared to 20 compared to 40, if I do this, right, 20 over 40 is a half, or 50%. Now, if I go to this box, right, notice the box is totally full. So it says this colder air has the same amount of water vapor. So I took the same amount of water out of this box, but now I dropped the air temperature. The air temperature that was 40 dropped down, as I wanted it to over here, to 20. So 20 degrees is the air temp, the top of the box. And so the air temp is now the same as the dew point temperature. So the air temp is 20, and over here it says, what is the dew point? So we're going to fill in this little blank. The dew point is also 20. The box is totally full. And therefore, if it's full, what's the humidity? 100%. All right? So here we were at 50% humidity. Over here on the right, we're at 100% humidity. But what I want to look at, and this is critical, students will ask me all the time, when is it going to start? Let's say it's the morning and first period in school, and then we know a snowstorm's coming sometime during the day. And students are getting excited. Hey, we're going to get out early today. When is it going to start snowing, Mr. Rocco? I tell them, actually, go on weather apps. You can go on any kind of weather app that has all the weather data and look at these two numbers. If you keep very close track of what is the air temperature and what is the dew point temperature outside, the closer these numbers get to each other, that means the more saturated the air becomes. And that means a better chance of precipitation. You're getting closer to 100%. And notice, like over here on the right, the air temperature and the dew point were equal. And that's really what you're looking for. You want them to be either equal or very, very, very close to have the best chance of precip. And so that's something I usually tell students if they want to, hey, when is it going to start raining? When is it going to start snowing? Look at the air temperature and the dew point temperature outside. And that will tell you. The closer they get, the better the chance is coming that it's going to start precipitating. All right, so this is just another example using that whole box idea. So it says, what is the air temp? Remember, if you go back to this one, the air temp was at the top of the box. So in this case, the air temp would be what? 60, right? Because see up at the top, it says 60. What's the dew point temp? That's when you reach saturation, which is where the top of the water is. That's 40. So what is the relative humidity? So you compare the dew point to the air temp. So that's 40 over 60. Well, 40 over 60 is what? 2/3. So that would be 66, if we round it, 67% humidity. This box is 2/3 full. It's 67% relative humidity. It says if the air temperature cools, so if we take this line, the air temperature, now cool it down toward the dew point, would humidity increase or decrease? Well, if you basically make the box smaller, keep the same amount of water, the humidity would go up, right? It's going to have more water in it, percentage-wise. If the air temperature goes up, what would happen to humidity? So now leave this water line where it is, leave the dew point at 40, but make the box bigger. So meaning now the temperature isn't 60, it might go up to 70 or 80. You're getting a bigger difference now. They're going the wrong way. Bigger difference, humidity goes down, right? The box will appear to have less water in it. If water vapor increases, now let's say we leave the temperature where it is at 60, but now we're going to raise the dew point. So when the dew point goes up, let's say now we put more water, and now it's not 40, let's say it's up here at 50. We made it 10 degrees higher. So we're getting closer to that original 60. 50 and 60 are closer. That means humidity would go up, and the dew point temperature would go up, because we're adding more water to the box. If water vapor decreases, let's take some of the water out of the box. Instead of having it up here, now this 40 drops down to 20. Right? The box is still 60, the air temp, but we drop the dew point to 20. Now the box only has water up to here. This would all be air. The humidity would go what? Down, and the dew point would go down. Hopefully all that makes sense. So dew point is when the air is totally saturated. you've reached 100% relative humidity. The air is totally full. At that point, that's when clouds start to form by the process of condensation. And again, remember C for cloud, C for condensation. So if you're looking for when is it going to start raining, when is it going to start snowing, some kind of precipitation, you want to keep track of the air temperature and the dew point temperature, and you want these numbers to get closer and closer, and again, equal would be the most opportune time for rain or snow. You want them to be exactly the same. That's the best time for rain or snow. The air is totally saturated. So it says, what is the one thing that affects the dew point then? The amount of moisture in the air, right? How much moisture is going to affect your dew point? You will typically hear meteorologists especially in the summertime, they'll talk about humidity. They'll say, let's say it's July and we get a hot, sticky day. And they'll say, whoa, dew points are on the rise. And what do they mean by that? They mean the dew point numbers are going up. As dew point numbers rise, so does the amount of moisture in the air. Somebody, I think I had a student the other day in class ask me that, like, when would it be considered, what would be considered not too hot, not too muggy, not too dry? Like, what's like a good humidity level? 50%, right? 50-50. The air has got some moisture, but not too dry, right? You don't want 20% or 10%, then it's too dry. You might have asthma issues, breathing issues. You might get nosebleeds. You have really dry, itchy skin, chapped lips. When it's like 10% humidity, that's too dry. You don't want it to be 90%, then it's really sticky out. But when you're looking at dew point temperatures themselves, typically 50 degree, it's usually in Fahrenheit, 50 degree Fahrenheit dew point, that's considered comfortable. 40s and 50s are good. When the dew points start getting into this range, 60, 70, 75, 80 Fahrenheit, your dew points are in the 60s, 70s, and 80s, that's considered muggy. Like, that's going to be your really sticky days. And if you pay attention next time we get to summer, as we approach that in a few months, and you start watching the weather, just turn it on from time to time on a really sticky day. You'll hear the meteorologists on television talk about that. They'll say, dew points are on the rise. We have a lot of hot, sticky air coming in. Yeah, and they'll say dew points are in the 60s, 70s. I've seen even some meteorologists will give you like a little chart to show you, like, it's not comfortable, it's more, unbearable or oppressive, or just, really, really miserable, right? You feel really sticky, hot, and yucky out. Yeah, those are 60s, 70s, like tropical. Like, if you go to places like the Amazon rainforest, you're talking 80 degree dew points. I mean, really just sticky, uncomfortable air, really, really moist. It says, what happens to the relative humidity as the air temperature, again, gets closer to the dew point? So again, when the air temperature and the dew point temperature, that saturation point, they're getting closer, humidity levels are going to go up, right? You're getting higher humidity levels as these two numbers get closer to each other. And again, when humidity goes up, so does the chance of precipitation. As humidity is higher, again, you're reaching 100% humidity, you've got a better chance of snow or rain or whatever precipitation, depending on if it's cold or warm outside. Right? Obviously, in the summer, it's going to be rain. This time of year, when the humidity is almost 100%, you're talking about snowfall. This was a screenshot I took. This was last year. You can see the date. So we had a little rain on February 10th of 2020. 10 o'clock in the morning. We actually have a weather station on top of the high school. It's on top of the high school gym. And that works with the monitor in the front. I don't know if that monitor's on right now, but you might recall when you walk into the lobby of the high school, middle school, or the high school area, you'll see the television right there. That would have the weather data. I think it's shut off right now, but we've had that on from time to time. Anyway, this was on the 10th from last year, and you can see, I just wanted to point out, see the humidity was at 100%. It was raining. And it tells you the air temperature was 35 degrees. So there's your air temp. And there's the dew point temp, was also 35. And again, just to show you, the air temp and the dew point are equal. That's why you reached 100%. And that's why it's raining. So all of these things are kind of interconnected. When you see these numbers the same, that makes this jump to 100, which makes this cause some kind of precipitation. In this case, it was rain because it was above 32. Right? It wasn't snow. This is something we'll get into probably next week. They're called station models. So major cities, are going to have a weather station. Around here, you're going to have one in Albany, Poughkeepsie, New York City, Boston, places like that, Philadelphia. And what they do is every 3 hours, they take all the different variables. They take, and this, I don't know if you can see this little tiny screenshot up here. This is in your reference table. We'll go over these next week. They're not that hard. They're actually fun to draw. They're called station models, and you take the information, temperature, what's the weather outside, visibility, the dew point, the wind, what's the pressure, etc., the cloud cover. You put all of that on a circle. So you start with a blank circle, and then you add all this information in a certain spot around the circle. For example, present weather would be a symbol that goes over here to the left. The actual air temperature in Fahrenheit always goes in the top left. So like city A right now, it's 70 degrees outside, air temp. The dew point number always goes in the bottom left. So I wanted to point this out because that'll come up sometimes on a test question. They'll say, they'll give you these two cities here. You've got city A and city B. This could be, wherever. This is, Miami, Florida is A. We'll put Miami. And, New York City is city B. And they'll say, who has a better chance of precip? Who's got a higher humidity? Well, what you could look at are a couple different things. In this case, you want to focus on the two temperatures, like I was saying earlier. The air temp in Miami is 70. The dew point temperature is 68. So the first thing you do is find the difference. Well, these are only 2 degrees apart, right? Over here in New York, it's also 70 degrees air temp, but notice the dew point is much lower. It's only 40 degrees, which means there's not as much moisture in the air. These two numbers are 30 degrees apart. So who has a higher chance of precip? Well, obviously Miami, because these numbers are very close. And who's got a higher humidity? Miami, because these numbers, again, are close. Over here in New York, low, right? Low chance of precip because the humidity is low. The difference, again, is very big between the dew point and the air temp. There's 30-degree difference. Over here in Miami is only 2 degrees. So because the air temp is so close to that saturation, that dew point, there's a good chance of rain. Now, there's another way you can look at it, and it's hard to see maybe in this little screenshot up here. You look at the actual circle. The shading in the circle will tell you the cloud cover. So if the circle is fully shaded, that means it's overcast. Well, obviously, if it's overcast, there's a good chance of rain. City B, New York, has no clouds, right? No shading means clear skies. Well, going to be a little tough to rain when there's no clouds in the sky. And so that's another indication you can tell by the shading in the circle, right? If this was not shaded in, these numbers wouldn't be close either. But telling you that the numbers are close, the air and the dew, and fully cloudy is both indicators that this is going to be raining sometime soon in Miami, whereas New York, the numbers are far and there's no cloud cover. So we'll get into these station models. I'll probably cover those next week. All right, so high dew point temperatures means there's a lot of blank in the air, a lot of moisture, a lot of water vapor. All right, some factors that affect evaporation. How quickly water will evaporate from the surface of the earth. Some of this is common sense. So temperature of the air and temperature of the water, right? Think about summer. In the summer when it's hot and the sun's higher, you tend to dry out. A lot of your lakes and rivers and creeks and stuff tend to run lower, like their level surface, water surface drops because higher temperatures mean more evaporation. So when you have hotter temperatures, that's going to evaporate more water. That's kind of common sense, I hope. Surface area. So people that have, let's say you have a driveway and it's a blacktop driveway, but you have a couple little low spots where you form puddles. Well, puddles, unless they're really deep puddles, your shallow puddles, when there's some sun, let's say it rains and then the sun comes out, those puddles will evaporate quickly because they're shallow and the water is up at the surface, right? It's not a deep, deep puddle. That has to do with surface area. So the more water you have up here on the surface, the faster it's going to evaporate. If you have a deep, like almost like a pothole, but it's really, really deep, the water is going to go down deeper. This water down here is not going to evaporate because it's not up at the surface, and you don't have as much surface area up here, right? This is, if you draw a line, right, the length of this line is very short. the length of this line is very long. So because there's more water up here on the surface and in B, that's going to allow it to evaporate. Whereas A, not as much water on the top, on the surface, and therefore less surface area, less, or a slower, I should say, evaporation process. So the more it's exposed to the air, the faster. That's surface area. Vapor pressure. Vapor pressure is related to humidity. So when it's dry outside, less humid, that's lower vapor pressure. On a dry day, you don't feel as sweaty because when you're sweating, the moisture is able to go off your skin and go into the air because the air has less pressure, vapor pressure. So when it's a drier day, less humidity, there's less vapor pressure in the air, which means moisture has an easy time leaving your skin and going into the atmosphere, and you don't feel sweaty on a dry day. On a humid day, right, you feel sweatier on a humid day because there's more humidity and therefore more vapor pressure. The atmosphere, when there's more moisture in the air, has a higher amount of pressure in it. The vapor creates a pressure. More and more water in the air, more and more pressure. So you're trying to get rid of that sweat. Sweating is trying to cool you off. That's what sweating is. It's a cooling process to make you feel comfortable, to release body heat. So sweating is a way for your body to cool. But if the atmosphere is full of moisture, there's no room for the water to go. There's no room for the sweat to go, I should say, because the pressure is too high in the air. And you can't lose the moisture. It has no room to go into the atmosphere. So what happens? The sweat on your body stays on your body. It can't escape. And that's why in the summer, when it's a humid day outside, you feel sweatier. Now, it doesn't mean you're sweating anymore. Like you're sweating your body, so that's basically the same amount in, all year round, doing the same activity, of course. Your body reaches what they call, and I don't know if you learned this in middle school, it's called homeostasis. So homeostasis is trying to keep your body at a constant balance. And so your body's, let's say you're sitting in a classroom this time of year in the winter, right? You might be sweating, but you don't feel sweaty because the moisture is able to go into the air because the air is cold and dry. But if you come and sit in my classroom, let's say you're in Mr. Rocco's room in June, when it's muggy in the classroom, you feel stickier, you feel hot, you feel uncomfortable because there's so much humidity in my classroom that raises the vapor pressure in the room, and therefore the water on your skin, the sweat on your skin can't escape. It can't evaporate into the air, and you feel stickier, right? Now, there's one way to get rid of that, and that's with a fan. And that's why you do that. So let's say it's a hot, sticky day and you walk into a classroom and you say, it's so muggy. Your skin can't let the water won't evaporate. It has no room to escape. The air is already full. It's got a high vapor pressure. So what do? You go stand in front of a fan and you're like, that feels good. Why? Because the force of the wind, or the fan, the artificial wind, is actually causing the water to blow off of you. So you're using a fan to blow that water vapor away. While doing that reduces the vapor pressure, right? And allows the water to evaporate. So a windy day or standing in front of a fan gives you comfort and you feel better on a sticky day because that's what it's doing. It's actually taking the moisture off your skin. It's blowing all that water vapor away and allowing your skin to evaporate, right? So this is just a silly example. Let's say you went for a hike in the woods and you fell into a stream or a brook and your pants get sopping wet. What kind of day is going to make them dry the fastest? Well, again, if you go back over your factors here, right? You want it to be hot because that's going to allow it to evaporate. You want more surface area, which we'll talk about that in a second. You want it to be a dry day, less humidity, right? You want dry. And you also want it to be a windy day. So all of those would help your pants dry faster. So a hot day, a dry day, low humidity, right? Low vapor pressure, and windy. And then I said you may want to take your pants off and lay them out because that's going to increase the surface area, right? So laying your pants out flat will increase the surface area. I usually don't refer to pants, but let's say a towel. So let's say you take a shower and now your towel is sopping wet. Or you go swimming in a pool, right? Either way. And you got a wet towel. Well, you want to let that air dry the towel. So you put it outside, but you don't want to crunch it up into a ball, right? Because it's not going to allow the water to evaporate quickly and dry it quick. What do you do with the towel? You hang it over a bar. You want to put it on a clothesline. I know some people still use clotheslines. Put some clothespins on it and stretch it out. You want to lay it out flat because that's going to increase the surface area and allow that towel or whatever to dry faster. So in this case, yeah, if you had pants and you lay them out flat, right, they're wet, it's going to help them dry quicker, right? So it's like, I don't know, some of you probably do your own laundry, right? You hang, sometimes I know when certain clothing, I partially dry them and then I put them on a hanger and let them dry the rest of the way by air, right? But you want to lay them out flat. You don't want to crunch them into a ball because that's not going to help the drying process. So that's all part of increasing the surface area. All right. If the air temperature, again, reaches the dew point or gets to it or just below it, what's going to start to happen? That's when the air is totally saturated. The water is going to start to condense, form your clouds, and you're going to start to have precipitation. So, again, you're looking for when that air temperature reaches that saturation point, which is called the dew point temperature. Now, how can you measure relative humidity and dew point? There is a way to measure it, and I touched on this a little bit in class last week, I think a few of my classes, but for those of you that don't come into school, let me go through this. It's a indirect way. You measure the amount of evaporation, which indirectly will measure how much water there is in the air. Let me explain what I mean by that. Evaporation is a cooling process. The drier the air, the more the evaporation, the cooler the evaporating liquid becomes. So I think the example I might have touched on in one or two of my classes last week, a horse. Let's say a horse is running the track, and the horse is running, ran so many laps around a track, and now the horse is overheated, right? And this could be you too. You run. How do you cool off? Well, or what do they do to a horse? Some of you maybe are an expert on horses. I am not, but I know they do this. So the horse is now overheated. It ran the track over and over again, lap after lap. They dump a big bucket of water on the horse, right? What does that do? That causes the water to evaporate. All of a sudden you start seeing steam come off the horse. Well, that's evaporation. Where is it getting the heat? Because remember, to evaporate, you're turning a liquid into a gas. So you just dumped a bucket of liquid water on the horse. Now that liquid has to turn to steam. Well, and vapor, how? It's taking the body heat away from the horse. Same thing with a person, right? Let's say you go run a marathon or you go run a 10K or 5K, whatever, and you're overheated. What do? You go through a sprinkler, you jump in a swimming pool, right? Let's say you jump in a pool. Now your skin has water on it, right? Well, you start to cool off when you get out of the pool because the water on your skin evaporates. And how does it evaporate? Well, it takes away the body heat. So jumping in a pool or dumping water on a horse is taking the heat away from the human or the horse and drawing it away. The water as it is evaporating and turns to a gas is drawing away the body heat. That's going to happen at a better rate if the air is drier. And again, I was just talking about that, about sweating. If the air is not dry and it's humid, that means no cooling. Because again, if it's humid outside, the air is totally full of moisture already. It's full. There's no more room for water to go. So you could jump in a swimming pool on a sticky, humid day and get out of the pool. The water will not be able to leave your skin. It's not going to be able to evaporate, and therefore you don't feel cool now because the air is already full and can't escape. Your sweat can't go anywhere. So when you evaporate, and this is probably the most important thing, evaporation, and the more you evaporate a liquid, the cooler the temperature becomes. So evaporation is a cooling process. Dry air allows for a lot of evaporation and creates a lot of cooling. Humid air doesn't allow much evaporation and therefore very little cooling. So on a dry day, evaporation is happening much better and things become much cooler faster. On a humid day, the opposite. Very little cooling, very little evaporation. That's where this instrument comes in. It's called a psychrometer. And it says, how is evaporation measured? With a psychrometer. This is a psychrometer. It has two thermometers on it. It's a very simple instrument. There's what's called a dry bulb and a wet bulb. The dry bulb is going to be used to measure air temperature. There's no little cotton or anything on the bottom. It's just a regular thermometer. And it says here, dry bulb measures air temperature. So it's just like, pretend we didn't have this wet bulb. Cross this one out. If you just had a regular thermometer, said, hey, what do you use this thermometer for? Oh, it measures temperature, the air temperature. Yep. So that's what the dry bulb is. The wet bulb is where now you're going to bring in this whole idea of evaporation. You pour water, and I'm going to go through the steps more specifically in a minute. Basically, you pour water on this wet bulb, this little piece of cotton at the bottom. And it's on this one, it's going to be on the left here. You'd soak this thing with water. You're then going to grab this handle and you're going to spin this thing. This thing spins around and around and around and around and around. You're measuring the amount of evaporation. If the air is dry, if it's low humidity out that day, that means the water that you poured on this wet bulb is going to evaporate quickly. The drier the air, the bigger the difference becomes between these two temperatures. Because what's going to happen is, this water on here is going to evaporate. The water is going to leave. It's going to go into the atmosphere, into the air. Remember I said on the last slide, evaporation is a cooling process. So if it's a dry day and more water evaporates, this temperature is going to drop. It's going to go way down. Like let's say the dry bulb temperature was 30 degrees. And that's in Celsius. It's a hot day, 30 Celsius. If it's a dry, hot day, like a desert, hot and dry, this is 30. When you put water on this water evaporates. This number might drop down all the way to 0 Celsius, okay, or 10 Celsius. Big difference between them. The bigger the difference, the drier the air is. And so that's one way to tell if it's a dry day or a humid day. You want these two thermometers to be further apart for a dry day. Now, let's say it's a humid day, very sticky, or even raining outside. Let's say you went outside with this thing and it's lightly raining outside. You're going to measure your air temperature, that's your dry bulb. You're going to put water on this wet bulb, and then you're going to spin this thing. When you spin it, well, if the air is already humid, if it's a sticky day, high humidity, or it's raining, which means 100% humidity, will there be any room for this water to go into the air? And the answer is no. The water is going to stay on this wet bulb. It's not going to be able to evaporate. This is not going to happen. And therefore, what will happen to this number? Nothing. It's going to stay almost the same or very close to the dry bulb number. And so the opposite would be the closer these numbers are, the more humid it is outside. So if it's a dry day, these numbers are further apart. If it's a humid day, these numbers are closer together. Okay. So let me go through the steps how to use this thing. So basically the first thing you do, you don't spin it right away. You take it outside, this psychrometer, and you just hold it by the handle. You don't put water on anything yet. You just kind of take it outside and you hold on to it. And the first thing you do is let it adjust for about a minute, 2 minutes. I would go more 2. And you write down the dry bulb number. So that's your air temperature. The psychrometers, I have some that are in Fahrenheit, but the charts, I'm going to show you the chart in the reference table. You want to use Celsius psychrometers because the charts are in Celsius. That makes it easier. So you're going to just hold the psychrometer out and you basically wait a couple minutes and then write down the air temp. Then, as I said a minute ago, you're going to pour water on the wet bulb. That's the one with the cotton on it. Soak it in water, and then you spin it for about 45 seconds to a minute. You don't have to go very long. Just count to 60. Keep spinning it at a nice, steady spin. Not too slow, not too fast, just right. You're judging to see if the water is going to evaporate or not. Then you find what's called the depression. The wet bulb depression is subtract. So let's say the dry bulb number came out to be 40 degrees Celsius. And then you put water on the wet bulb, you spun it, and let's say the wet bulb number came out to be 30 degrees Celsius. You then want to find the difference. Well, 40 minus 30 is, 40 minus 30 is 10. So that is what they call the wet bulb depression, the difference between the wet and the dry. You need that difference. You're going to need two things: the difference between the two numbers, and you're going to reuse the dry bulb number, and I'll show you the chart here in a minute. This number, the dry bulb, and the difference to help you find the humidity and the dew point temperature. There's a reference table, two charts. So I won't use the 40 and the 30. Let's use some different numbers. Let's say you're using a psychrometer, and let's say, thinking off the top of my head, let's say the dry bulb number is 20 degrees Celsius. So the dry bulb number is 20. Then you pour water on the wet bulb, spin it for a minute, and then, hey, that rhymes, spin it for a minute. And then you get a wet bulb number of, 17. So it dropped a little bit. That was the wet bulb. So they're close, but not exact. So you got a dry bulb number 20. You spin it. You read the wet bulb number. It came out to be 17. The first step you do is find the difference. Well, the difference is 3. That's called your depression, wet bulb difference. There's two charts on page 12. So you probably should pause the video at this point and go to page 12. All right, so hopefully you paused it. If you go to page 12, the top chart is dew point. The bottom chart is relative humidity. This is in a percent. What percent of the air is full of moisture? This is in degrees Celsius. What is the saturation point? What temperature would this 20 have to reach to be 100% humidity? Okay. So I know the dry bulb was 20 and the wet bulb's 3. You'll see across this, you have columns and rows. Across the top row, see the top row, are differences between the wet and dry. These are they call them the depressions, the differences. So what was my difference? Well, my difference was 3. So what I'm going to do is find 3. That was my difference right here. I'm in this column. So I go down this column. Then over here, notice on the left-hand side, I've got dry bulb numbers. Now, these are even numbers. Somebody will say, well, what happens if you had an odd dry bulb? Then you have to make an estimate between the two even numbers. Right? Use common sense, and I'll show you that in a minute. So let's say the dry bulb number we said was 20. So I go down. Now, be careful. These are negatives. I go down to positive 20, way down here. Here was 20. And then I basically go down the 3 column until I hit that 20 row, and I find a number. So if I come across 20, because that was my dry bulb, and down the 3 column, oops, doing a horrible job drawing a straight line, you get the idea, I get to a number. What number do I get? 15 degrees. That means my dry bulb was 20, my wet bulb was 17. I'm not at 100% humidity yet because I'm not saturated. The dew point on that particular situation would be 15. That means if this 20 dropped and cooled down to 15, I would finally reach saturation and be at 100% humidity and have a very good chance of seeing some kind of precipitation. That's my dew point temperature for that particular day at that particular time. But 15 is my dew point. Now, I use the same two numbers and the same column and the same row on the bottom chart. So if you look on page 12, you'll see the top chart is dew point. The bottom chart's humidity, which is telling me what percent of the air is full of moisture. So I had a difference of 3. So here was my 3 again. I go down the 3 column. And I had a dry bulb number of 20. Here was my 20. I come across 20. And I came down the 3. And I have what percent? 74%. So when I had a dry bulb of 20 and a wet bulb of 17, my atmosphere, or the air, is 74% humid right now, which is pretty high. That's a high humidity. And it makes sense. These numbers are only 3 degrees apart. And as we said earlier, the closer these numbers get to each other, the better the chance of precipitation and the better the humidity is. And I'm at 74% humidity. Now, you will notice one particular column. When the numbers are the same, when there's no difference between the dry and the wet. See this 0? No difference. What do you see all the way down? 100%, right? You reach saturation. That's why you see 100 in this column. And notice what happens to numbers. The bigger the difference, when I go out here 5, 10, 12, 15 degrees apart, and I look at my numbers here, my relative humidity percentage, look at my percentages when I head toward this bottom corner. Notice I'm going from hundreds and 90s and 80s, and I'm getting down to what? Single digits and teens, right? Very low humidity levels. Because why? I'm at a bigger difference. And again, we said that earlier. The bigger the difference between the numbers, the drier the air is, right? It's less humid outside. Okay, let's do a couple quick practice questions. I know this video is running long. Student uses psychrometer, measures the wet bulb 10, dry bulb 16. What's the dew point? So again, the first thing you do is find the difference. 16 and 10, the difference is 6. Now also be careful of what they're asking. They want the dew point. So then make sure you're using the correct chart. You're going to use the top chart for dew point, the bottom chart for humidity. So if they ask for humidity, you're going to go to the bottom chart. So don't use the wrong chart by mistake. So difference is 6, and then again, you need to know two things, the difference and reuse the dry bulb. So you're going to use the dry bulb a couple times. One to find the difference between them, and then also to go for the row across. So I had 16 dry bulb, 6 is the difference. So let me go to my chart. Oops, that's the wrong way. I'm on the dew point chart now. 6 was my difference. I'm going to come down the 6 column. And 16, right, was the dry bulb. I come across 16, and I get 4, plus 4. 4 is my dew point. So I'm going to go back to my choices, and there it is. Now, let's see. Sometimes they fall for the I call it the distractor, the trick. What if I use the bottom chart by mistake? It was 16 dry, and 6 is the difference. If I was, let me use the bottom chart by mistake, and I went 6 down and 16 across. Yep, there it is. See, if I did 16 and 6 on the wrong chart, see, this is humidity instead of the dew point. Notice what I get. I get 45%, but notice what they did in that choice. They turned it into 45 degrees. That's a distractor. Try not to fall for that. They're betting on the fact that a student uses the wrong chart by mistake. All right, here's one where you have an odd one. Let me just do this one. Dry bulb is 13, and the wet bulb's 10. So you do it the same way. 13 and 10, the difference is 3. But now you have an odd number. So you think, what are two even numbers on either side? 12 and 14, right? On either side of 13. So I have to go to 3 is the difference, but I want to look at 12 and 14. And again, this was asking me for dew point, so I use the top chart. So I'm going to go 3 down, and then I had 13. So because I only have even numbers, I look at 12, would give me a dew point of 6. 14 would give me a dew point of 9. Well, 13 would have to be a number between. So I got to be more than 6, but less than 9. So what does that leave me? 7 or 8. And then I go back to my multiple choices, and there's 7. All right. Let's do this one. What is the relative humidity when the dry bulb is 4 and the dew point is -4? All right, so this is a little trickier. It's almost a little backwards. They're telling you the dry bulb's 4. They're telling you that the dew point is -4. So how do you handle that one? So I'm going to go to the dew point chart first. I got to use one chart to help me with the other. It's a little trickier. Dry bulb 4, dew point -4. I got to find the difference first. So dry bulb is 4 and the dew point's -4. So let's go to the dew point chart. Dry bulb is 4. I'm going to start here at 4. That's my dry bulb. I'm going to go across until I hit -4. Here's -4. What's my difference? 3. Now I take this 3 column down and this 4 column across, and I transfer it to the bottom chart because they asked me for the humidity, but I didn't know the difference. They gave me this number. So you see how you're kind of working backwards a little bit. This was given, not this. So I had to figure out that difference. So now I know it's 3 down and 4 across. I go to the bottom, and I use the humidity chart, 3 down, 4 across. So I come across 4 down the 3, I get a humidity of, looks like 56%. Hopefully that was a choice. Whoops. Yep, right here. Okay. And one more. I know this video is running long, sorry. What is the wet bulb temperature if the temperature, air temp, now remember, air temp is dry bulb. So I know the dry bulb's 16, and they're telling me the humidity is 71%. So again, working a little bit backwards. I'm going to go to the humidity chart. I know the dry bulb's 16 and the humidity is 71%. I got to find the difference. So dry bulb 16. I'm on the humidity chart. So I start with the 16 dry bulb. Humidity is 71%. I shoot across here until I hit 71, just like I did on that last question. I find the difference. Now the difference is 3. Now, typically when you use that psychrometer, let me go back. Oops. Like I was saying earlier, this thing usually is going to spin out with water and moisture is going to leave. This is going to become cooler. Remember, evaporation is a cooling process. As it says here, cools when spun. So this number is usually either going to be equal to or lower than. Very rarely, I can't even think of a situation, but very rarely would the wet bulb number ever be higher than the dry bulb. The wet bulb number is either equal to or lower than. So in these kind of questions, you always want to make the wet bulb number lower than the dry bulb. So with that in mind, and go back to that question, it was 3 degrees difference, and the dry bulb was 16. So if the dry bulb is 16, I'm going to subtract 3 degrees away from 16 because I want the wet bulb to be 3 degrees lower than the dry bulb. So 16 minus 3 is 13. And hopefully that was a choice. Yes. Now you see what they did here. They gave you a couple of distractors. They gave you 3 because that was saying, oh, the student realized the difference was 3, but that's not the correct answer. You want to take away because what the wet bulb is going to evaporate water and cool. It's going to get colder. Notice they gave you 19 because that's the student that says, oh, I'm going to add the 3 degrees. So 16 plus 3 gives you 19. But that's the wrong way. Evaporation, the number becomes lower for the wet bulb. So if they ask you for the wet bulb number, rule of thumb, take away the difference from the dry bulb. So that's how I did 16 minus 3 gave me 13. So 13 is the correct answer there. All right. One of the assignments this week is to actually figure out the dew point humidity using that chart. There's a column to find the difference. Like, for example, this first one, -8 is the dry bulb, -5 is the wet bulb. Well, you can even ignore the negatives, right? That's a difference of 3. So you're going to fill in 3. Then again, remember, use the 3 going down and use the dry bulb. So it's this column on over here and this difference going down. This is going to be the across, right? That's the one you use across. I'll do the first one as an example. So that's -8, and the difference is 3. And you have to find the dew point and the humidity. So you got to use both charts. So I got -8 and 3. So I'm going to go to dew point first. -8 is here. 3 is here. So you come down the 3 and across the -8. I get a dew point of -29. And then I go to the bottom chart and do the same exact thing. -8 is here. Difference was 3. I come down the 3 column, and across the -8, I get 13%. So this is 13%, and the other one was in Celsius. I get -29 Celsius. So you want to fill in that chart like that. -29 Celsius and 13%. So that's on one of the assignments for this week. Very easy. Just use the chart. Take your time. That was a very long video. I apologize. Please do the 3 assignments. The lab isn't due this week. It's due next week. It's another one of those gizmo ones. Take your time. Use the gizmo. Read carefully. I don't think it's hard. The last one wasn't hard either. It just took a little bit of time, but you have a couple weeks to work on that. And I will talk to you guys soon.